Hello everyone, welcome to the numbers playlist by IPMAT. Once again, I am Yogesh and today we are doing the 12th session in this playlist, okay. I hope in all the previous sessions you have gone through the concepts and have gained confidence, because we did not just learn the concepts, we solved a lot of questions, confusing questions, right, special cases, questions in which special cases are encountered, right. And now we are going to touch the topic factorials, okay. So factorials are again very important. I mean, it's one of the, I would say, most frequent topics in number system. You can get questions from factorials in almost every examination. In fact, we also saw factorials while we were doing the Wilson remainder theorem. So there's a remainder theorem as well, which is related to factorials. Wilson remainder theorem, you have done it earlier, okay. Now we are going to see other type of questions that can be asked from factorials, okay. So before that, if you want to attempt a daily quiz for IPMAT, okay, so we are releasing daily quizzes for IPMAT in which 15 questions are there, and link to this free quiz will be in the description at the top, okay. As I keep saying, if you want to practice mixed questions of numbers from all the concepts, there's again a playlist link at the top, okay, numbers practice playlist. You can access that as well to directly solve questions, okay. And you go to these quizzes, you can attempt 15 questions daily, make it your daily goal, okay. And all these questions are made by IIM students, okay, who have cracked the IPMAT exam earlier and now they are making content and all, fine. So August quizzes are under August, September quizzes under September, October, and this will keep going on till the exam, and this is basically a daily goal by iQuanta that the students have to complete, fine. Let's go ahead. Let's talk about factorial, okay. So factorial is basically a kind of function only, which basically does continuous product till 1 of any number. Now, if you read the definition, the factorial of a non-negative integer n is the product of all positive integers less than or equal to n, okay. So factorials are only defined for non-negative integers, okay, non-negative. That means factorial is defined for 0, 1, 2, 3, 4, 5, 6, 7, 8. It is not defined for non-integers, okay. You cannot find 3.5 factorial, okay. So 0 factorial makes sense because it's a non-negative integer. 1 factorial makes sense, 2 factorial makes sense. Factorial does not even exist for fractions. You cannot say 4 by 5 factorial, okay. So that is the thing, and negative numbers ka factorial does not exist, it does not make sense, okay. So it's basically continuous product till 1. So you can see here, if I am writing n factorial, it can be written as n into n minus 1, then n minus 2. So this n is being reduced by 1 every time and being multiplied with its predecessor, and we are reaching 1 and stopping, isn't it? So suppose I ask you guys 5 factorial, you will say start with 5, 4, 3, 2, 1, multiply all the numbers, okay. And that is how you calculate the factorial value. So factorial values can be huge. If there is a big number, say 147 factorial, this can be a huge number, okay. It can be a huge number, we cannot calculate the value straight away, fine. So there are some examples over here, 5 factorial, 4 factorial, 1 factorial, and there is a very special factorial value, that is 0 factorial. 0 factorial is equal to 1 always, okay. 0 factorial is also 1 and 1 factorial is also 1. So there is a proof behind 0 factorial, why 0 factorial is equal to 1, okay. You must be thinking, if 0 is the number involved, obviously the value should be 0, right, but 0 factorial is equal to 1, and factorial does not make sense for negative numbers. Suppose I ask you guys, what is minus 5 factorial? So minus 5 factorial means it will start with minus 5 and then we will keep multiplying the predecessors. I mean, we will keep reducing 5 by 1, 1, 1 every time and keep multiplying the numbers ahead, right. So minus 5, if you reduce 1, you get minus 6, minus 7, minus 8. And this will forever keep going into negative, 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 it will never stop, unlike this situation where we start from a positive integer and we stop at 1, isn't it? So it's not defined for negative numbers as well. I hope this is clear. These are the very basics of factorial. And one more thing, sometimes you need to transform factorials according to the condition is our question, okay. So how to do that? Suppose they ask you n factorial. N factorial is n into then n minus 1 into n minus 2 into so on, so on, so on till 1. So from n minus 1 we are multiplying all the numbers till 1. So that becomes n minus 1 factorial, okay. So this n can be written separately, while this entire thing can be written as n minus 1 factorial. So this is one way. Suppose I ask you, how can you write 5 factorial? That can be written as 5 into 4 factorial or 5 into 4 into 3 factorial. So that is how you can transform factorials to solve some questions, okay, where you have simplification involving factorials. I hope that is clear. But now what kind of questions are asked in factorial, that is very important. So generally they ask you maximum power of a prime number in n factorial. So they will give you a question and say that what is the power of 7 in 100 factorial. You need to know how to calculate it, okay. So power of a prime number, because obviously what happens, suppose I give you 10 factorial, okay, you will be writing 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, isn't it? This will be 10 factorial. And if they ask you what is the power of 7 in this, so basically how many 7s are being multiplied in 10 factorial, there is only one 7, isn't it? So power of 7 or power of the prime 7 in 10 factorial will be 1, okay. So in 10 factorial, power of 7 will be 1, there is only one 7 available over here. But what if they ask you the power of 2 in it, okay. So where do we have 2's present? There is a 2 here, because 10 can be written as 2 into 5, yes or no? 8 can be written as 2 cube, 6 can be written as 2 into 3, 1 2 is here, 4 can be written as 2 square, and then 2 is over here as well. So there is a 2 ki power 1. If you multiply all of them, you know, all the 2's will be multiplied. So 2 ki power 1 into 2 ki power 3 into 2 ki power 1 into 2 ki power 2 into 2 ki power 1. So 2 ka total power will be 1 plus 3 4, 4 plus 1 5, 5 2, 7, 7 and then 8. I hope this is clear. This is very important, okay. But this is not the correct way to solve it. I mean, what if they give you 100 factorial के अंदर 2 का power क्या होगा? Then you will be lost. It will be a big number. You cannot distribute. I mean, you cannot factorize each and every even number as 2 into something and count the total powers of 2, isn't it? It will be difficult for a big number. So we have some shortcut related to this concept. We'll learn it in a while. Next, maximum power of a non-prime number in n factorial. Now, the question here was find out the power of 7, power of a prime number in 10 factorial. What if they give you find power of a non-prime number in a factorial? So suppose they give you that in 100 factorial you need to calculate power of say 6. So then you have to count how many 6's will be multiplied, isn't it, inside the product of 100 factorial. So that is what we have to learn. There is a shortcut to do this as well. Third, find the number of trailing zeros. Okay, this is trailing, make it trailing, okay. It's trailing zeros. What's a trail? Trail is continuous zeros, yes or no, the trail of zeros. So trailing zeros basically means how many zeros are there at the end of a number. So suppose I write a big number, 100 factorial, isn't it? In 100 factorial, if you find out the entire product, entire value of 100 factorial, there will be so many zeros at the end. Why? Because there are 2 zeros in 100 itself, then 90 will give a 0, 80 will give a 0, 70, even those numbers which are multiple of 5 will also give zeros, isn't it? So there will be a lot of zeros. There is a shortcut to count them, we will learn this as well, but you have to remember the term trailing zeros. That means they are asking you how many zeros, continuous zeros are at the end of the number when you write its value. So when you write 100 factorial, its complete value, big number, how many continuous zeros are at the end of 100 factorial. So we have a shortcut for that, okay. Remainders, Wilson theorem we have already done related to factorials in the earlier sessions. You can go and find it out in the playlist. Other equations based questions, okay. There can be some equation around factorials, we will solve some questions and you have to solve it. Rightmost non-zero digit in a factorial, this is not very important. I mean, I have not seen it in IPMAT, but so this can be asked, okay. I mean, there are less chances of coming in the exam straight away, but still because it is a part of factorials, we should learn it, fine. Let's go ahead and try to do some questions, okay. And it's better to learn through questions only, okay. I'll keep explaining the concept as well. Find the number of factors of 10 factorial. So 10 factorial is a small number, okay. I mean, compared to 100 factorial, it's a small number. So we can definitely write down the prime factorization of 10 factorial and then we know how to find out the factors, isn't it. So 10 factorial is basically 10. So what is 10? 10 is 2 into 5, isn't it? Into 9. 9 is 3 square, isn't it? Then 8. 8 is 2 cube. Then 7. Then 6. 6 is 2 into 3. 5. Then 4. 4 is 2 square. I am writing the prime factorization straight away, okay. This is 10. This is into 9. This is 9, okay. This is 8. This is 7 over here, okay. This is 6. This is 5. okay, 2 square is 4, then next will be 3, 2 and 1 does not matter, okay, I mean 1 does nothing to the product. So, what is the total power? I mean, we have to write down the prime factorization. So, 2 ka total power will be 2 plus 3, I mean 2 ki power 1 plus 2 ki power 3 will be 2 ki power 4, 2 ki power 4 plus 1 2 ki power 5. We have to add 2 more to it, to 2 ki power 7 and 2 ki power 8, isn't it? What about 3's? 3 ki power is 2 over here and then 1 over here and then 1 over here. So, 2 plus 1 plus 1, that means 3 ki power will be 4. Then what do you see? You also see 7, only 1 7, so 7 ki power 1. Then you also see 5, isn't it? There is a 5 here, there is a 5 here, so 5 square, isn't it? So, this is the prime factorization of 10 factorial. You know how to find out the factors if you have the prime factorization. You simply increase the powers by 1 and multiply them all. So, 2 ki power is 8, so 8 plus 1 into 3 ki power is 4, so 4 plus 1. Then 7 ki power is 1, so 1 plus 1 and 5 ki power is 2, so 2 plus 1. And you can calculate this product to find out the total number of factors in 10 factorial. I hope this is clear. There is something in which we spent a lot of time because we did 2 sessions in factors where in one of the factors I told you the basics and concepts, second one we solved a lot of questions, okay. So, if you have forgotten the concept, go back and revise it, okay. I hope you know how to find out the total number of factors of 10 factorial. If this would have been a bigger number like 100 factorial, okay, then it would have been very difficult and they will not ask such an absurd question in the exam, okay. So, the next question is power of 7 in 100 factorial, okay. I just told you that they will be asking a question around power of a prime in a factorial, okay. What do we have? Power of 7 in 100 factorial. So, this is a prime number, yes or no? 7 is a prime number, it has only 2 factors, 1 and 7, yes, it is a prime number. How to find out the power of 7 in 100 factorial? If you expand 100 factorial by writing it as 100 into 90 into 98, it will be very difficult, okay. So, the shortcut is, if you have to find power of a prime, okay. So, the shortcut is, if you have to find out the power of a prime in any factorial, then say P is your prime, okay, P is your prime number and you have to find its power in n factorial. Then power of prime in n factorial is given by n upon P, okay, and we will find out its greatest integer value. How to do it? I will tell you, okay, and then n upon P square, then n upon P cube and so on, so on, so on, okay. My n is 100 over here, my prime P is 7. So, I will start with 100 by 7, okay. I am not taking factorial here, just the number 100 and I will find out the integer part of this fraction. Then 100 upon 7 square and again its integer part. If I do 100 upon 7 cube, over here we see that the denominator is 7 cube now. 7 cube is bigger than 100, right. So, if I do this part, okay, 100 upon 7 will be 14 point something, isn't it? 14 point something, its integer part, okay. You do not have to round off, integer part only. What is the integer part of 14 point something? It is 14. Rest, this decimal is the fractional part. So, we will just take 14 out of it, okay. 100 upon 49 will be 2 point something, its integer part, it will be 2. And the moment we reach here, 100 upon 343 will give me 0 point something. Whenever we have a fraction in which denominator is bigger than the numerator, we always get answer in 0 point something something, right. So, this will get 0 point something something. What is the integer part of 14 point something? It will be 14. Integer part of 2 point something is 2. Integer part of this is 0. And all the further fractions like 100 upon 7 upon 7 to the power 4, this will also have value as 0 point something, its integer part will be 0. So, it is not useful to write down all of this, okay. It wastes a lot of time in writing down these because we will only be writing till here. So, just remember, we will only write till the point the value of the fraction is greater than 1. The moment it becomes lesser than 1, and when does a fraction become lesser than 1? When denominator is bigger than the numerator, okay. So, the moment you see over here that the denominator has become bigger than the numerator, you will stop, okay. So, that is how you have to find out the power of a prime in any factorial. We can do this with one more prime maybe, okay. Let us try with say 11. So, 100 by 11 and its integer part. Should we do 100 upon 11 square? The moment I do 100 upon 11 square, we will get 100 upon 121. So, denominator is bigger, we will not do that. So straight away 100 upon 11 will be 9 point something, right? And its integer part is 9. So the power of 11 in 100 factorial is 9. 9 is the answer. Okay. But what if they ask me the power of 12 in 100? Because 12 is not a prime number. 7 was a prime number, 11 was a prime number. What about 12? 12 is not a prime number. So the approach for 12 will be different. Okay. But before that, we have another question. I mean, this is also a question related to power of a non-prime number in 100 factorial. Is 21 a prime number? No. 21 has 4 factors, 1, 3, 7, 21. It's not a prime number. So whenever you have something like this in which you have basically a number which is non-prime like 21 and you have to find out its power in 100 factorial, what will you do? You will first write down the prime factorization of 21. 21 can be written as 3 into 7. So it's basically a product of just 2 primes, isn't it? Now tell me, in 3 and 7, among 3 and 7, which one is bigger? 7 is bigger, right? The bigger prime in such cases is always called the limiting prime. Okay? Why? See. And we will use 7 to calculate the power here. How? We will do 100 by 7. I mean, we will not calculate the power of 3 here. We will just calculate the power of 7 here. I will tell you the logic first. But if you calculate the power of 7 here, it will be 100 by 7 plus 100 by 7 square. Should we write 100 by 7 cube? No, because there the denominator will become greater than the numerator and we will be getting 0, 0, right? So this will give us 14, integer part of this, and 2 will be integer part of this, that is 16. So power of 7 is 16, isn't it? Why did we not find out the power of 3? Does 3 not matter over here? It does. But 3 is something which will have more power in 100 factorial because 3 occurs very frequently. 3 will be there in 3, 6, 9, every multiple of 3, that is a part of 100 factorial because in 100 factorial we are going to get a long product, isn't it? 100, 99, 98, 97, 96 till 1. So from 100 till 1, if you check how many multiples of 3 are there, there is 3, there is 6, there is 9, 12, 15, 18, all of these multiples of 3 will be giving a 3 to the product and hence the power of 3 will be very large. If you calculate power of 3 in 100 factorial, so 3 is a prime number, it will be 100 by 3 plus 100 by 3 square, that is 9, okay. Then 100 by 3 cube, that is 27, then 100 by 3 ki power 4, that is 81. We will not go beyond this because now then 100 upon 3 ki power 5 will become 243 and that will give me 0 point something, integer part of 0 point something is 0. So we will go only till here, the point where numerator is greater than the denominator, okay. This will give us 33 point something, so integer part is 33. 100 upon 9 will give me 11 point something, integer part is 11. 100 upon 27 will give me 3 point something, integer part is 3. 100 upon 81 will give me 1 point something, integer part is 1. So 33 plus 11 is 44, 44 plus 4 is 48. The power of 3 is total 48 in 100 factorial. So in 100 factorial, I just found the power of 2 primes, 3 and 7, I have written them like this, okay. We need the power of 21 in 100 factorial. To make a 21, we need a 7 as well as 3. So now we will check to 21, what is the maximum power that we can assign. Can you assign power 48 to this? No, because if you assign power 48 to this, 7 will become 7 ki power 48 and we don't have 7 ki power 48, we have 7 ki power 16 only. And that is why, because we have lesser 7s, we can only give the maximum power 16 to 21. The moment you give 17 over here, it becomes 7 ki power 17, but we don't have 7 ki power 17. The maximum power of 7 available is 16, right? So the remaining 3s, I mean 3 ki power 16 is utilized over here. What about the other powers of, because there will again be 3 ki power 32 as well, yes or no? Because total power of 3 is 48. So 3 ki power 16 is used over here, 3 ki power 32 will still be remaining. What is the use of this? It is of no use in making 21 because we already have the required number of 3s. So what's the power of 21 in 100 factorial? It is 16. 16 is my answer. But we don't need to go till this point, okay. The moment you see such a question and you are able to see that, okay, this given number which is non-prime is simply written as the product of 2 primes, you can always say that the bigger prime is the limiting prime. So right away you calculate the power of 7 in 100 factorial, which is 16, and you can simply declare this as your answer even without doing all of this. This was just for conceptual understanding, but in such cases always decide which is the bigger prime, find out its power right away. Okay, suppose the question would have been find out the power of say 35. 35 in 100 factorial. 35 can be written as 5 into 7. So, to find out the power of 35 in 100 factorial, you simply choose the bigger prime. Okay. What if the product is something like this? Say they ask you the power of 105, power of 105 in 100 factorial. 105 is made up of 3 into 5 into 7. Here we have 3 different primes. Okay. Which is the biggest prime over here? It is 7. So, simply calculate the power of 7. This is the concept of limiting prime. It becomes the limiting prime. It puts a limit to the power of 7 that can occur in 100 factorial. This prime puts the limit to the power of 7 that can occur in 100 factorial. So, I hope this is clear. Okay. What if the question is like this? In the earlier question, we were simply having product of 2 primes, right? Isn't it? Like 21 was 3 into 7. Yeah. 35 was 5 into 7. What about this? Power of 80 in 1000 factorial. Write down the prime factorization of 80. It is 2 ki power 4 into 5. Now here don't do it blindly like the previous question, okay? Just because you are able to see 5 as the bigger prime over here. See, 2 ki power 4 is a non-prime number. Yes or no? This is a non-prime. 5 is a prime. In previous question, we had product of 2 primes. In this question, we have a non-prime and a prime. So, when you have product of different primes, then you can use that method, okay. But in such cases, where the prime factorization of the given number has some power, then you have to follow a different approach. Just notice the difference between these two, okay. Here the prime factorization of my number 21 just had 3 into 7. So, there was no power to 3 and 7. So, we just took the bigger prime and we straight away calculated the power, we got it. Here also in 35, 5 into 7 bigger prime is this, they did not have any power. But here in 80 there is a power to 2, right. Even though 2 is prime, 5 is prime, but 2 has some power. In such questions you have to be very cautious, okay. How to do such questions? In such questions, first you find out the power of 2, then you find out the power of 5, and then you will use it to calculate 2 ki power 4. So, suppose in 80 if I find out power of 2, in 80 factorial, so suppose in 1000 factorial I find out the power of 2. Obviously, in 1000 factorial we have to find out the power of 2, power of 5, and then we will do something, okay. So, 1000 upon 2, right, then 1000 upon 4. So, there is a shortcut to this as well, okay. You do not need to write all those fractions again and again, you simply write down 1000, okay, and you break it like this, okay. What do you get? 2 divides this how many times? 500 times, isn't it? And this would have also given you 500, so you will count it. What would have been the next fraction? 1000 by 2 square, that means 1000 by 4, and that would have given you a 250. Because we are finding out the power of 2 here, I will divide this 500 again by 2, and that will give me 250. I am also getting a 250 here, so we will count it. So, you have to count all the numbers in this row and find out their sum, because we are actually calculating the sum of 500, 250 and so on, so on, so on. But leave this 1000, okay, the bigger number that you had initially. Then 125 times, yes or no? And you have to keep dividing it by 2. This is not prime factorization, okay. This is now, if you divide it by 2, what do you get here? 62 point something, you just take 62, okay. Then further by 2 we get 31, then further by 2 we get 15 point something, right, 15 only. From 2 we divided 7.5, just take 7, okay. 2 3 point something, right, 3 only, and then finally 2 1ja, okay. Find out the sum of all these numbers, okay. If you find out the sum of all these numbers, it is better than writing fraction again and again over here, isn't it? So, that is a shortcut, okay. What if we find out the sum of all of these? 500, 250, 750, 750, 125 is 875, 875 and 60 is 935, 935 and 2 is 937, 937 is 968, 968 and 50, 983, 983 7, 990, 990 and 4 is 994. So, the power of 2, See, I just calculated the power of 2. Why did I calculate power of 2? Because 2 was a prime involved in 80. Okay. So, power of 2 is 994. But what do we need? We don't need this. We need the power of 2 ki power 4. So, to turn this into 2 ki power 4, what is the maximum power that you can take so that you get power of 2 ki power 4? Obviously, this number will be achieved when 4 is multiplied with something. So, if from 4 you divide this, 4 to the 8, okay, we get 19, then 4 to 16, we get 34, 4 8 the 32. This is the maximum power that you can take common over here, okay. I hope it is clear. Because we had power of 2 in this 1000 factorial as 994, I just calculated the sum of all of these. I got 994. To calculate the power of 2 ki power 4, we just have to take, this will be achieved when these two numbers are multiplied, hai na? So, if I take 2 ki power 4 inside, what is the maximum power that I can assign outside? It is 248, not more than that, because if you make it 249, this will cross this power, okay. I hope it is clear. So, the power of 2 ki power 4 is this. What about power of 5? Power of 5 in 1000 factorial. So, again you can write down 1000 and you start dividing by 5 now, okay. 5 say this will go 200 times, 5 say 40 times, then 5 say 88 times, 5 1ja, and we will stop. Calculate the sum of these, 240, 249. So, power of 5, it is 249. Yes or no? Now the question is in its final phase, okay. You just calculated the power of 2 and power of 5 in 1000 factorial. You have got the power of 2 ki power 4 as this and 5 as this. You need an 80, and 80 is formed when you have 2 ki power 4 into 5. Yes or no? So, write it like this. What is the maximum power that you can give to 2 ki power 4? To 2 ki power 4, you can give a maximum power of 248. So, try to write down 248 over here. But we also have to take care of, because 248 has been assigned to 2 ki power 4, we also have to check whether 5 can take power 248 or not. How much was the power of 5 available over here? It was 249. And here we have 248. Yes or no? So, see, this is 80 now, this is 80. 2 ki power 4 can take maximum power 248, yes. Can 5 take power 248? Is it available 248 for 5 ki power? Yes. We had more power for 5, we had 249, but the maximum we can take common for these both, it is 248, right. So, I told you that when the number given over here, it is a simple product of some primes, you just choose the biggest prime and find out its power, that will be your answer. But when the prime factorization has some power, in that case what you have to do is, you have to separately find out the power of 2 first, separately the power of 5 first, and then you have to find out power of 2 ki power 4 by distributing the power like this, and 5 ki power 2 will straight away calculate like this only, we got 249. Now, after combining these two, 2 ki power 4 into 5, what is the maximum power you can take common? That you have to decide from here. It's an easy question, okay. If you try by yourself, you can easily do it. What about this? Power of 10 in this. 10 can be written as 2 into 5. So, it's very easy for me. Simple product of 2 primes, which is the bigger prime 5. So, we simply have to find out the power of 5 in 1000 factorial. That will be same as power of 10 in 1000 factorial. So, you know it, 1000. If you start finding out the power of 5, 5 say this will go 200 times, 540, 5 8 are 40, then 5 say this will go 1.6 times, we will just write 1. So, add these numbers, okay, that is 249. So, this is 5 ki power 249, right, and this will be my answer for the question, because 5 is the limiting prime. I told you this concept in the first question, right. I hope it is clear. Sometimes they will write the question like this, number of trailing zeros in 150. So, finding out number of trailing zeros is same as finding out power of 5 in 150 factorial, 150 factorial, right. Why? Because if you are finding out the number of trailing zeros at the end of 150 factorial. That simply means कि if you have to generate a 0, to generate a 0 you need 10, to generate 10 you need a 2 and a 5, and we obviously know that there will be lesser 5s than 2s in the product of 150 factorial, and that is why 5 again becomes the limiting prime, understood, and we will simply calculate power of 5 in 150 factorial. So, in trailing zeros question you do simply like this. Total number of consecutive zeros at the end of 150 factorial is again the same thing, okay, nothing different. So, they can either write trailing zeros or number of consecutive zeros at the end of 150 factorial, or they can sometimes write power of 5 or say power of 10, all of these are same, okay. Just the way of writing the statement is different, but ultimately you calculate the same in all. Power of 5 in 150 factorial, you know how to calculate it. Power of 10 ke liye you will, it's not a prime number, so you will write it as 2 into 5, 5 is the limiting prime, find out the power of 5. That's how you have to do it. What about this question, power of 385 in 403 factorial? This is a non-prime number because see, 385 is divisible by 5. So, if you divide it by 5, 5 7 is 35 and 5 7 is 35. Again 5 into 7 into 11. This is a plain question, okay. I mean, in this 385 is simply a product of 3 primes without any power. Choose the biggest prime over here, this is the limiting prime. In 403 factorial, find out the power of 11, that will be 403 by 11 plus 403 by 11 square is 121. We will not be going to 403 upon 11 cube because 11 cube will be bigger than 403. So, just find out the interior part of these. 11 divides 403, 11 3 is 33 and we will get 73 remaining. So, 11 3 is 60, 36 point something, interior part will be 36 plus 121 3 is 360 something. So, if we do 121 4 ja, that crosses 403. So, 3 point something, interior part is 3, we will get 39. 39. This is the power of 11 and that actually means the power of 385 in 403 factorial, okay. I hope this is clear. The moment if this factorization had some power of 5 or 7 or 11, we would have followed the previous approach, okay. Or suppose they ask you a question like this, what is the power of 12 in say 403 factorial, okay. 12 can be written as 2 square into 3. So, remember, find out power of 2 then power of 2 square. So, in 403 factorial, or say not 403 factorial, let us make it a smaller number so that we do not have to calculate a lot, say 40 factorial. In 40 factorial, find out power of 2. So, 40, we are finding power of 2 first and then later we will find out power of 2 square. So, 220 ja, 210 ja, 25 and 2, say if we divide 5 we get 2.5, we will write 2 only and 2 1 ja, and find out the sum of these numbers 30, 35 and then 38. So, 2 ki power total is 38 in 40 factorial, okay. What about 3? 40, if you divide by 3 you get 3 13 ja 39, 13 point something, we will write 13 only, 3 4 ja 12 point something, I mean we will write 4 only, okay, and 3 1 ja, right. So, 13 4 1, that gives you 18. So, 3 ki power is 18. Now, see what is the power of 2? 38, but we need power of 2 square. So, power of 2 square that you can give maximum is 19 over here because maximum power available for 2 is 38, 2 square if it is inside we need 19 outside and 3 ki power is 18. You actually need 2 square into 3 ki power. So, 2 square into 3, what is the maximum power you can give, 18 or 19? Obviously 18, not 19, because if you give 19 over here, the power of 3 is going to become 19, which is not possible. Maximum power of 3 possible is 18, and that is why the answer to this question is 18 if they ask you power of 12 in 40 factorial. I hope it is clear. So, this way you can make some questions on your own which are which have a prime factorization in which there are some power. So, like you can find out power of 72 in 100 factorial or maybe power of 144 in 1000 factorial. Try them and get your answer. If there is any doubt, comment. So, this question is, what is the remainder when 1 factorial plus 2 factorial plus 3 factorial so on so on so on till 13 factorial? Key power is also the same, 1 factorial, 2 factorial, 3 factorial till 13 factorial is divided by 5. Okay. So, you know the remainder ke rules, isn't it? If this number is divided by 5, 5 can disturb the bases, yes or no? How is 1 factorial written? It is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, right? 6 factorial is 720 and so on so on so on. This 13 factorial will be a big number है ना, having some zeros at the end. So actually this is my base. This base I have written, okay, 1 factorial, 2 factorial, 3 factorial, 4 factorial, like this. You are actually dividing it by 5. I am not taking the power into consideration for a while, okay. You are dividing it by 5. 5 will divide 1 and remainder will be 1. 5 will divide 2, remainder will be 2. 5 will divide 6, remainder will be 1. Replace it, okay. 5 will divide 24, remainder will be 4, right. What about the rest of the part? Every number here onwards has a 0 in the end, yes or no, till 13 factorial. So if 5 divides them, all of them will give remainder 0 because they have 0 in the end, and 5 divides every number that has a 0 at the end, right. So they all will give remainder 0. So what do we get ultimately over here? 1 plus 2 plus 1 plus 4. So that is 3, 3 plus 5, 8. 8 to the power, now we need to use the power given over here, and this will be divided by 5. But again 5 can divide this 8 and it will become 3 to the power this entire sum which is in the power divided by 5. Yes or no? I hope this is clear. If we divide the base by 5, because 5 always disturbs the base, yes or no, the divisor is 5 and it can disturb the base. It can divide the base and replace it with respective remainder, and that is 3 ki power something divided by 5. So now I am finally writing my question as 3 to the power this entire sum divided by 5. Now 5 cannot disturb 3 anymore. We need this power actually, okay. How to do it? See, 5 and 3. This is a big power question, because if you find out the sum of this entire number, it will be a huge number, yes or no. And if it's a huge number question, huge power question, we will use Euler, okay. What does Euler say? Euler says that if divisor and dividend are co-prime, are they co-prime 3 and 5? Yes, they are co-prime. So we will use Euler. In Euler, we have to find out the Euler of 5. Euler of 5 is a prime number, its Euler will be 1 less than it. So 5 minus 1 is 4. You have to check my Euler remainder theorem if you are not able to understand what I am saying, okay. I am just dividing, I am trying to divide the power by the Euler of 5, okay, because it's a big power question and divisor and dividend are co-prime. So I can apply Euler. Euler of 5 is 4. What is the use of this Euler value? It disturbs the power or divides the power to reduce it. The main function of Euler remainder theorem is to reduce the power, yes or no. So my power is 1 factorial plus 2 factorial plus 2 plus 3 factorial plus 4 factorial plus something up till 5 factorial, 6 factorial till 13 factorial. This has to be divided by 4 because we want to reduce this power by dividing with Euler value. So 4 divides 1, remainder is 1. 4 divides 2, remainder is 2. 4 divides 3 factorial. 3 factorial is 6. 6 divided by 4, remainder is 2. 4 divides 4 factorial. In 4 factorial, we have a 4. It will give remainder 0. 5 factorial will have 4, remainder 0. 6 factorial is also divisible by 4, remainder 0. All the factorials, so on, will give remainder 0. So this is what I get, okay, and this is divided by 4. So 5 is divided by 4. The remainder when this power is divided by 4 is 1. So the new power here becomes 1, and that becomes 3 divided by 5. Answer will be 3 only. Yes or no? This is how you have to use the concept of factorials in remainder problems, okay. What is the remainder when 34 factorial is divided by 17 cube? I brought this up because I wanted you to revise Wilson theorem and one more concept that I taught in remainder theorems, that is when 34 factorial is divided by 17 cube, what will be the remainder? See, if this would have been a question of Wilson theorem directly, Wilson theorem basically works for primes, isn't it? If P is a prime, then P minus 1 factorial mod P divided by P is P minus 1, and P minus 2 factorial divided by P gives you remainder. You know the meaning of mod, right? It's remainder, gives you 1, and P minus 3 factorial, if you divide it by P, you get remainder P minus 1 by 2, where P is a prime number, okay. In 34 factorial, if you write down 34 factorial very smartly, you can write 34 into 33 into 32 and so on. There will be a time when I will reach 18 and 17 and 16, 15, 14, right, like this, and I will again reach 1. I am dividing this by 17 cube, that means 17 into 17 into 17. One of the 17s will cancel with this 34, isn't it, and give me a 2. cancelled. I am cancelling right now, not finding out remainder. Okay, this 17 will get cancelled with this 17. Okay, and give me 1. Yes or no? There is no cancellation for this 17, it remains like that. Okay, so what is the new product that I have? The new product that I have is 2 into, from 33 onwards I'll go till 18, right? And then from 16 I'll go till 1. So 16, 15, 14 till 1 can be written as 16 factorial, yes or no? And this 17 which is at the bottom, it divides the numbers over here. If 17 divides 33, the remainder will be 16. If 17 divides 32, remainder will be 15. If 17 divides 31, remainder will be 14. So 16, 15, 14, okay, till this product is going till 18. So 17 divides 18, we get 1. So this is again a product of 16, 15, 14, 13, 12, so on till 1. So can I further write down this as 16 factorial? Yes. Isn't it? My question has been entirely transformed. I had a 2 here. I got a 16 factorial here. I got a 16 factorial here, and this entirely I am dividing by 17. But do not forget these two 17s that cancelled themselves. In remainder questions, whenever there is a situation where I am cancelling something from the divisor, it has to be multiplied later at the end. Okay. So what did I cancel so far? The cancelled part should always be written safely so that it can be multiplied later. This is my question right now after cancelling and doing all the bits and stuff over here. And I hope it is clear. You write it down more clearly, you will understand it. Okay. I hope it is clear. First of all, I expanded 34 factorial like this. Then I had 17 cube, 17, 17, 17, 17 divided this 34. And it will cancel 2 times. So right now this is the cancellation part going on. Okay. Many of you must be thinking 17 divides 34, remainder should be 0. I have not started remainders right now. I am just doing cancellation. 17 divided 34, we get 2. 17 divided 17, cancel 17, we get 1. This 17 cannot be cancelled. So 2 17s were cancelled, we have written them over there. But now we have 33 into 32 till 18, isn't it? So this 17 divides 33, 32 till 18. We get 16, 15, 14 as respective remainders till 1. So this entire product becomes 16 factorial. Similarly, 16 till 1 again becomes, it's a product 16 factorial. So 16 factorial into 16 factorial into 2, that is what I have written. Isn't this a perfect case of Wilson? Because here this is my prime and it is dividing a factorial 1 less than the prime. So this is the case that I am going to use. Yes or no? So 17 divides 16 factorial, remainder will be p minus 1. That means 17 minus 1, 16. This will also give 16. What do I finally get? 2 into 16 into 16. 2 into 16 into 16 divided by 17. 17 divides 16, remainder is minus 1. 17 divides 16, remainder is minus 1. So 2 into minus 1 is 2 divided by 17. 2 divided by 17, remainder is 2. The final remainder that I am getting is 2, but it is not the actual remainder. Okay. We cannot forget these two 17s that were there. So final remainder will be the remainder I have got right now, and the remaining 2's will be multiplied back because they were cancelled earlier. This will be my remainder when 34 factorial is divided by 17 cube. I hope it is clear. If you have any doubt, comment. Okay, I'll definitely reply. Now we have a couple of questions which are related to factorials, not really factorials, but factorial is there. Okay, unit digit of 17 की power 27 factorial. Last session that we did was on unit digits, isn't it? You know what to do in unit digits. We forget the other digits, so we have to calculate unit digit of 7 की power 27 factorial. And I told you that whenever you have unit digit questions, try to divide the power by 4 and find out the new power, because the cyclicity of 7 is 4. In fact, for those numbers as well where cyclicity is not 4, okay, like 5, 6, maybe 9, in those numbers also you can divide the power by 4 to find out the unit digit. So divide 27 factorial by 4, because every fourth power of each digit repeats. चाहे आप 7 की पावर 4, 7 की पावर 8, 7 की पावर 12, सारी पावर्स को अगर मैच करते हो सबका यूनिट डिजिट सेम होता है. तो एवरी यूनिट डिजिट का फोर्थ पावर हैज़ सेम यूनिट डिजिट. ओके, आई मीन टू से दैट अगर 2 की पावर आप 1 की बात कर रहे हो तो 2 की पावर 1 के बाद क्या आएगा अगला जिस पे यूनिट डिजिट रिपीट होगा? 2 की पावर 5, 2 की पावर 9, 2 की पावर 13. इजंट इट लाइक दिस? वी हैव 7. तो अगर आप 7 की पावर 1 लो या 7 की पावर 5 लो या 7 की पावर 9 लो या 7 की पावर 13 लो, सबका यूनिट डिजिट सेम होगा. सो फोर्थ पावर पे सबका यूनिट डिजिट रिपीट होता है. एंड दैट इज वाई जब भी यूनिट्स के क्वेश्चंस आए ऐसे हाई पावर वाले, आप सीधा पावर को 4 से डिवाइड करके देखो. ठीक है, what do we get here? If you divide 27 factorial by 4, what is the remainder? The remainder will be 0 because 27 factorial में एक 4 होगा, 4 और 4 आपस में पूरा डिवाइजर completely cancel हो जाएगा तो 0 remainder आ जाएगा. तो that means reduced power will be 0 क्योंकि पावर को साइक्लिसिटी से डिवाइड करने पर नई पावर मिलती है. सो इसका आंसर क्या हो जाएगा? 1 will be the unit digit. बट यहाँ पे एक सोचने वाली बात है. आई होप ये क्लियर होगा आपको. यहाँ तो बेस में ऑड नंबर है, बट अगर यहाँ गलती से इवन नंबर हो गया, सपोज अगर ये क्वेश्चन होता 18 की पावर 27 फैक्टोरियल, इसका यूनिट डिजिट, तो हम लिखते 8 की पावर, बिकॉज ये हम हटा देते, राइट. अगेन मैं क्या करता, इस पावर को 8 की साइक्लिसिटी भी 4 होती है, 27 फैक्टोरियल को अगर मैं 4 से डिवाइड करता, रिमाइंडर तो मेरा 0 ही आता. यस और नो. तो अब अगर मैं गलती से इस पावर को रिप्लेस कर दूंगा 0 से, आई जस्ट डिड फॉर 7, राइट, मेरा यूनिट डिजिट क्या आ रहा है? 1. क्या ये सही है? नो, बिकॉज 1 अगर आ रहा है यूनिट डिजिट, दैट मीन्स मेरा एक ऑड नंबर होगा ये. बट ये तो एक इवन नंबर था शुरू में, बिकॉज इवन की पावर 27 फैक्टोरियल तो इवन आना चाहिए, तो यूनिट डिजिट ऑड कैसे आ रही है? इसका मतलब यहाँ पे हम क्या यूज़ करेंगे? वही वाला मेथड जो बताया था इस क्वेश्चन में फंसने के लिए, बचने के लिए. इस क्वेश्चन में ऐसी सिचुएशन में अगर आप फंस जाते हो तो बचने के लिए क्या करना होता है? ये देखना होता है कि जो पावर है क्या वो एज अ 4 का मल्टीपल लिखी जा सकती है. तो ऑब्वियसली यार 27 फैक्टोरियल को अगर आप 4 से डिवाइड करके रिमाइंडर 0 निकाल रहे हो तो पक्का ये 4 का मल्टीपल होगा. तो 8 की पावर जब भी 4 की यानी 4 का मल्टीपल होती है तो यूनिट डिजिट क्या होती है? 8 की पावर 1 इज 8, 8 स्क्वायर इज 64, यूनिट डिजिट 4, 8 की पावर 3 इज 512, यूनिट डिजिट 2, एंड 8 की पावर 4 इज 512 इंटू 8, दैट मीन्स कुछ 6 यूनिट डिजिट आएगा, है ना. तो हमेशा इस क्वेश्चन का आंसर 6 होता. फिर इज इट क्लियर? ये बहुत इंपॉर्टेंट है. ओके, यहाँ पे गलती मत करना, ठीक है. अगर ऑड नंबर है बेस में तब तो पूरा सही है, बट इवन के केस में आप एक बार चेक कर लीजिएगा. ओके, सिमिलरली वी हैव दिस 54 की पावर 127 फैक्टोरियल. अब देखो 5 हटाओ, 12 हटाओ, 16 हटाओ, 14 हटाओ, व्हाट विल वी गेट? 4 की पावर 127 फैक्टोरियल प्लस 7 की पावर 113 फैक्टोरियल प्लस 9 की पावर 115 फैक्टोरियल प्लस 3 की पावर 129 फैक्टोरियल. इसकी यूनिट डिजिट बतानी है. ऑब्वियसली आप सारी पावर्स को 4 से डिवाइड करोगे, 4 4 4 4 4, ये सब 0 दे देंगे. बट चलो 7 की पावर ये 0 देगा तो 7 की पावर 0 आएगा, यानी कि यूनिट डिजिट 1. यहाँ पे भी 9 की पावर 0 आएगा तो यूनिट डिजिट 9, सॉरी 1 नॉट 9, ओके, बिकॉज 9 की पावर 0 जाएगी. पावर इज डिवाइडेड बाई 4 एंड 129 भी 4 से डिवाइड होगा तो यहाँ भी 3 की पावर 0 आएगा, दैट मीन्स 1 यूनिट डिजिट यहाँ भी आएगी, है ना. तो अर्लियर ऑल्सो देवर ऑड नंबर्स, बिकॉज ऑड की पावर समथिंग है तो यूनिट डिजिट 1 आ रही है तो वो भी ऑड की होती है. तो यहाँ तो सब सही है. बट जैसे ही आप 4 की पावर 127 फैक्टोरियल को अगर आप 4 से डिवाइड करते हो, है ना, बिकॉज पावर्स को हम 4 से डिवाइड करते हैं और रिमाइंडर निकालते हैं, तो 0 आ जाएगा. तो 4 की पावर 0 आ जाएगा. 4 की पावर 0 इज यूनिट डिजिट 1. और यूनिट डिजिट 1 कैसे हो सकती है ना, यूनिट डिजिट 1 तो पॉसिबल नहीं है, वो तो ऑड डिजिट की होती है. तो इवन नंबर था शुरू में, तो ये क्या है? ये 4 की पावर 4 के टाइप का नंबर है. और 4 की पावर 4 जब होता है तो यूनिट डिजिट कितनी होती है? 4 की पावर 4 इज 256, दैट मीन्स यूनिट डिजिट 6 आएगी इसकी. नाउ वील गेट द न्यू यूनिट डिजिट, दैट इज 9. आई होप इट इज क्लियर. ओके, so that's it with today's class. In the next class we'll come up with some more practice questions, okay, difficult ones. Till then you explore factorials, try to solve a couple of questions around power of prime, power of non-prime, okay, unit digit, and next class we'll be talking about some difficult concepts, some other concepts, okay, related to factorials. So that's it with the session today. I'll see you in the next class.